Good afternoon, ladies and gentlemen. Misal, can you hear me?
Yes, sir.
Okay, very good. Thank you very much. Just I want to make sure that my voice is clear. Guys, I hope you're all doing well after a long holiday. I hope you have enjoyed this Khmer New Year festival, and most of you might, I think, still must be in your provinces if you're from provinces. Okay. Anyway, I have shared the schedule for this week in Telegram, so we are going to follow the schedule. And once again, if you are busy or you have class at those times, actually you can just watch the video, because why am I doing this again? To compensate some skipped classes, okay, due to some public holidays. I think I skipped 1 or 2 classes, okay, the kind of compensation. And also the classes will not be like 15-minute long, okay, it will be like 35 or 40 minutes, so they're short, and we are going to meet like 5 or 6 times, and most probably 6 times, okay, I will see. And hopefully today or tomorrow I'm going to finish this chapter. And if we have more time, 1 hour, I'm going to do some practice problem solving session also, okay, kind of revision. And after that, if we have time, we will start chapter 6. And also I have mentioned in Telegram group, you're going to have one more quiz. I mean, 95%, okay, and I'm still thinking, and I will let you know soon. And it will be at scheduled time next week on, like, for example, section 1 to 3 on Wednesday, and the section and other sections on Thursday, and 2 sections on Friday. It will be paper-based, okay? There will be around maybe 5 or 6 questions. So you have to solve them in like 45 minutes, okay? And this is a kind of preparation for final exam, because after all, your final exam will be paper-based. And that means that you have to come to the campus and solve the questions and show all your work. Most probably, again, of course, I don't know what kind of, about the situation, and day by day hopefully it's getting better and better, so that everybody is able to come to the campus. Okay, guys, and also if you have any questions anytime, you can ask me. So what are we going to do today? Last time, if you remember, we talked about the fundamental theorem of calculus, and because you're having online class, that's why I skipped this proof. And also proof is really beautiful, and I really suggest the students, if you are really interested in learning math or in math, okay, you need to have a look and try to prove it yourself, okay? Why is it important, and how we are actually constructing or see the relation between the derivative or derivative and the integral, okay? So today we are going to talk about indefinite integrals and the substitution methods. That is a method how actually what is it? We are going to integrate some functions. And also chapter 7 actually is all about integration methods. After we have actually defined these definite integrals, you will see that most of the functions, they are not easy to integrate. And that's why we have to develop the integration techniques. But step by step, we will do this, okay? So today we will start with this method. What is it? The substitution methods. And if we have more time today, we'll talk about substitution and area between curves. And tomorrow we will do revision. And Wednesday, Thursday, Friday, we will see maybe, what is it? We will start chapter 6 and we'll see. Just a second. Okay. Okay, indefinite integrals and the substitution methods. All right, so especially we are going to use the differential here a lot. Let's start with this example, okay? Maybe 2 examples. After that, we'll talk about it. We'll give its theorem. And as you practice more and more questions, I hope you will have, how to say, clear picture about this technique or method. Now, suppose that we are given this integral. Okay, how do we integrate this function x cubed plus x to the power of 5 and times 3x squared plus 1 dx? And if you remember, when we define the differential of a function, right? So let me just write here the solution. Okay. right-hand side, the differential of a function f, right? We have defined this as f prime of x and the dx. So we are going to use differential a lot in integrating functions, okay? Now, if you look at this one, x cubed plus x, right? So if you differentiate this function, x cubed plus x, we will get 3x squared plus 1. Okay, so now if I introduce this variable, that's why u is equal to x cubed plus x. So what is du? Du dx, if you differentiate it with respect to x, it will be 3x squared plus 1, right? So that means that from here, actually the derivative or differential of u is, what is this, 3x squared plus 1, and here we have dx. Okay, so we are going to substitute this. That's why this method is called substitution method. Okay, so now this instead of this 3x squared plus 1 dx, right? I can just write here du. And how about this x cubed plus x? That's equal to u. At that time, let me just label this integral by I, this indefinite integral. Then this I becomes integral here. Here we have u and the du. As you see here, a single substitution actually made this equation much simpler, right? And easy to calculate. So here we have x cubed plus x, that is u to the power of 5, and here we have 3x squared plus 1 dx, that's equal to, what is it, du. So now we know how to differentiate. This is just a polynomial function, right? It's antiderivative or indefinite integral of this eu to the power of 5 is u to the power of 6 over 6, and plus here we have constant c. And now we have to actually leave our answer in terms of the original variable. So here we have 1 over 6 times, what is u? U is 3, I mean, not 3, it's actually x cubed. That's equal to x cubed plus x to the power of 6 and plus c. Okay, so that means that if you differentiate this function, we will get this integral. Another example, find the integral square root of 2x plus 1. Okay, so now actually this 2x plus 1, let me just introduce this variable. U is equal to 2x plus 1, right? Now what is the differential of u then? Du is equal to 2x plus 1 prime. If you differentiate, that's equal to 2 and dx. Right? So now I'm going to use this substitution. Instead of dx, I can write here 1 over 2 du is equal to dx. Just considering these substitutions, now our integral, this I becomes I is equal to integral square root of, what is 2x plus 1? 2x plus 1 is, here we have u. And how about dx? Dx is equal to 1 over 2 times du. So this 1 over 2 is a constant. We're using the property of definite integral. I can write here du. So which is equal to 1 over 2 integral, and this u is u to the power of 1 over 2 and du. You know how to integrate this. That's equal to 1 over 2 u to the power of 1 over 2 plus 1. That is 3 over 2. And here we have 3 over 2 plus c. Well, actually, this 3 over 2, right, goes up. So that's equal to 1 over 3. And let me just write here. How should I write this? Okay. So u is equal to 2x plus 1 to the power of 3 over 2 and plus c. Okay. So that is indefinite integrals. We are just integrating, because to evaluate the definite integral, right, first we have to find the antiderivative of this function. And that's why first we have to develop the techniques, and after that we can actually evaluate most of the integrals. After this observation, let's give the theorem here. This theorem says that the substitution rule, if u is equal to g of x, is a differentiable function whose range is the output values, so the set of all output values of this function, whose range is an interval I, and f is continuous on I, then if you're given this integral in this form, integral f of g of x, and here we have g prime of x dx. So that's just equal to f of u du. Why? Again, here we are just using the differential, right? So this g prime of x and dx, right? And actually it's just a differential of some function. What is this? It's just differential of g of x. And after that, we are just introducing this variable. U is equal to g of x. At the time it becomes, what is it? F of u, and here we have du. Find the integral. Question 3. Secant squared 5t plus 1 dt. Before we continue, you have to remember that identity. What is that identity? We know that actually 1 plus tangent squared of x is equal to secant square root of x, right? So that is one thing. All right, and okay, that means, and also what function's derivative is secant squared? I think I don't have to. I think we don't need this one, right? What function derivative is secant? It is tangent, right? Because we know that tangent of x, and let me just write it d dx, right? So that's equal to secant squared of x. So now from here, I can just write this one, d tangent of x is equal to secant square root of x, and here we have dx. Okay. So now let me actually introduce our variable as tangent or 5t plus 5t, 5t plus, all right. So u is equal to 5t plus 1. Okay. So at the time here we have du will be equal to 5 times dt, right? Or 5 dt, because the derivative of 5t plus 1 is equal to 5 dt. Now using this one, okay. So our integral, let's say that's I, integral I will be equal to integral. So here we have secant squared 5t plus 1, that is u, but instead of dt, right, I can write 1 over 5 du. So this 1 over 5, let me just write here 1 over 5, and here we have du. Which is equal to, let me just keep 1 over 5 outside this integral, as secant square root of u du. What is it? It is just the tangent of u, right? So here we have 1. So 1 with respect, now we are differentiating, integrating the constant function 1 with respect to tangent of u. So that's equal to 1 over 5, right? So that is tangent of u plus c. So dot, dot, dot. So the answer is, what is it? 1 over 5. We have to write everything in terms of the original variable. That is tangent of u. What is u? U is 5t plus 1 plus c. Okay. Another example, find the integral. Integral cosine of 5 theta minus 3 d theta. Solution. Okay. Again, here, let me introduce this variable. U is equal to 5 theta minus 3. At that time, du will be equal, if we differentiate this 5 theta minus 3 with respect to theta, that is 5 and d theta, right? So from here, this I is equal to integral cosine of 5 theta minus 3, that is u. Instead of this d theta, we can write 1 over 5 d. So 1 over 5, again, now you know how what we are doing here. We just keep it here, du. Now, what function's derivative is cosine of u? That is sine. So 1 over 5 sine of u plus c. So that's why dot, dot, dot. Actually, the answer to this question is, or the indefinite integral of this function is 1 over 5 times sine of u. U is 5 theta minus 3 plus c. Okay, example 5. Guys, once again, about this methods, the only thing you have to do is, we are just working on the method. So you have to integrate as many different functions as possible. That's the only way to improve your integration skill. And the next question is, all right, here we have x squared and sine of x cubed dx. Okay, so if I just rearrange this, let's say this I is equal to integral, and here we have sine of x cubed times, let me just put it in brackets, and here we have x squared dx. Now I can see this more clearly. Here we have x squared dx. If I just introduce this variable, u is equal to x cubed. And what is the differential of u? That is 3x squared dx. Or instead of this x squared dx, we can write 1 over 3 du. So now I will just make this substitution here. 1 over 3, just keep it here. 1 over 3 integral, right? And here we have sine of x cubed. X cubed is u instead of dx, right? X squared dx. We write 1 over 3 du. 1 over 3 is already written here. Here we have du. So that is equal to 1 over 3. What function's derivative is sine? That is minus cosine. So here we have minus cosine of u plus c. Okay. So now I will just write the final answer. Then the answer is minus 1 over 3 and cosine of u. What is u? U is x cubed. And plus, here we have c. Evaluate the integral. Another example. X for x plus 3 dx. Okay, how do we do this? Because if you have a function, right, not under the square root, it's not a big deal, especially polynomial function. But if you have a function under the square root, it actually sometimes it may be a troublesome. So I'll try to take this 4x plus 3 out of the root, or at least express as a single variable. So if I introduce this variable, u is equal to 4x plus 3. Okay, so at that time, here we have du becomes 4 times dx, because u, if you differentiate u with respect to x, that's equal to 4, right? So that means that instead of dx, I can write 1 over 4 du. So now next thing is also we have x right outside the square root. How can I express x in terms of u? So now if you solve this equation for x, or if you just make x the subject of this formula, then we get here x is equal to u minus 3 over 4. So I will make this substitutions, okay? So again, suppose that our integral is I. So here we have I is equal to integral, and x is 1 over 4 times u minus 3 times, and how about 4x plus 3? That's equal to square root of u. So I can just write it as u to the power of 1 over 2. And how about dx? Dx is equal to 1 over 4 du. So here we have times 1 over 4 du. Okay, so that's it. Now here we have 1 over 4, 1 over 4. It's just constant number, 1 over 16 integral. And just expand this. Here we have u times u to the power of 1 over 2. So that is u to the power of 3 over 2 minus, and here we have 3 times u to the power of 1 over 2. And here we have u. They are just power functions, so we know how to differentiate them. So that's equal to then 1 over 16. Okay, so here we have u to the power of 3 over 2. It will be u to the power of 3 over 2 plus 1 over 3 over 2 plus 1 minus, the second one is 3 times u to the power of 1 over 2 plus 1 over 1 over 2 plus 1. And here we have constant. Now, if you simplify this, Okay, let me just write everything in terms of also, what is it? The original variable, that's x. The first one is here we have 3, right? It is 5, 1 over 16. You just keep it here. So that is 2, 2, 2, and 5. So 2 over 5 times, what is u? U is 4x plus 3 to the power of 3 over 2 plus 1 is 5 over 2. Here we have 5 over 2 minus, and here we have 3, right? Is 1 over 2 plus 1 is 3 over 2, and 3 cancel each other. That's equal to 2 times u. That is 4x plus 3 to the power of 3 over 2. To the power of 3 over 2. So plus, and here we have constancy. So if you differentiate this function, you will get, what is it? X times square root of 4x plus 3. That is a little bit more challenging question comparing to the previous questions. Okay, another example. Actually, we have 8 examples. We have 2 additional questions, and we'll see. So evaluate the integral z dz, and here we have cubic root of z squared plus 1. Again, the idea here is we have to try to take this function outside this root, or just express this as a power function of a single variable. To do this one, solution, let me actually introduce this variable. U is equal to z squared plus 1. Okay, now from here, du, what is the differential of this function with respect to z? That is 2z and dz, right? Or actually, if we just take this 2 to the left-hand side, z dz is equal to 1 over 2 du. So using this substitution, now we are going to evaluate our integral. So let's say this I is equal to this, and the I is equal to definite integral here. And so this d, see, I get 1 over 2 du. So 1 over 2, let me just keep it here. And here we have du over, and what is z squared plus 1? That's equal to u, right? So that is u to the power of 1 over 3. Or that's equal to 1 over 2 integral u to the power of minus 1 over 3 and du. And just a power function, you know how to integrate this. Here we have 1 over 2 times u to the power of 1 over 3 plus 1 over minus 1 over 3 plus 1 plus c. So that is equal to minus 1 over 3 plus 1, that's equal to 2 over 3. 2 over 3, 3 over 2, right? 2 over 3, 3 over 2, that is 3 over 4. And what is, let me just write here first, that is 2 over 3 plus c. So dots, 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 the final answer would be 3 over 4. U is z squared plus 1 to the power of 2 over 3 and plus c. So if you differentiate this function, we will get the function in the integral, right? Okay. The integrals of sine squared of x and the cosine squared of x. So to do this one again, we are just going to use one trigonometric identity, that is, let me use some different colors here. Is black. So we know that actually we put in chapter 1, I guess, what is cosine of 2x? That's equal to 2 cosine squared of x minus 1, or 1 minus sine squared of x, 2, right? So from this, right, I can express this cosine squared or sine squared in terms of this cosine. Okay, actually in the math or in calculus, we call this the reduction formula. Okay, in general, instead of here we have in power 2, for example, if we have 3 or 4 or 5, you will use the same technique. In just one step, we cannot evaluate this. We can only reduce the power of these trigonometric functions. So from the first one, then what is cosine squared of x? Cosine squared of x is equal to 1 plus cosine of 2x over 2. And the sine square root of x is equal to, what is it? 1 minus cosine 2x over 2. Okay, I'm just going to use this one to find the integrals of this function. So let's have the first one. Okay, the first one is I1. Integral of, what is it? Sine square root of x dx. So what is sine square root of x? That's equal to 1 minus cosine of 2x over 2. Integral 1 minus cosine of 2x over 2 dx. So which is equal to 1 over 2 is just a constant number, right? And how about this one? It is x. And what function's derivative is cosine of 2x? That is sine of 2x minus, actually, is 1 over 2 times sine of 2x and plus c. Because if you differentiate sine of 2x, it's equal to 2 times cosine of x, right? This 1 over 2 times 2, they cancel each other. So that's why we have 1 over 2 here. And how about the second part? For cosine, integral cosine square root of x dx. That's equal to integral, let me just keep 1 over 2 here. So that's equal to 1 plus cosine 2x dx. So which is equal to 1 over 2. And here we have 1. What is the antiderivative of 1? That is x. And how about cosine? Because cosine, it must be minus. So here we have sine is cosine. Cosine is all right. So plus 1 over 2 sine of 2x and plus c. Okay. Or if you just open the brackets here, we can write 1 over 2x plus 1 over 4 sine of 2x plus c. Okay. We have two challenging questions. Maybe I'll do this later in our revision part, okay? And that's all for this, what is it? Indefinite integrals and the substitution methods. Now we will use this method to evaluate some definite integrals in our next class, okay? So let's have break for 20 minutes. I think I will continue our class at 2:05, okay? At 5 minutes past 2 o'clock. See you after 20 minutes.